So it works on vapor. This is the actual practical cycle that your RSA is working on. Okay. Okay. For this particularly, they will ask you draw the pH and TS diagrams for vapor compression diagrams, because this is important. Okay. They will ask you draw diagrams for pH. What is H? H is enthalpy. Okay. And TS diagram. Okay. So I'll draw these diagrams for you first.
No, sir.
See, normally all the sessions that I'm taking, it is a combined written and your orals. ठीक है, दोनों साथ में ही हो जाएंगे तो बढ़िया है, right?
सर सीओपी में क्वेश्चन पूछा था सर, हाउ टू इम्प्रूव सीओपी करके।
How to improve
सीओपी।
COP? अभी आपको फॉर्मूला दिख गया। ठीक है, how will you improve it? Now
बाय
suppose
इंक्रीजिंग
if
T1।
my this thing top, ठीक है, top it is getting increase, will my COP increase or decrease?
Increase, sir.
If
इंक्रीज।
I'm able to extract more heat, so it will increase, right? So in time, अब इसमें क्या क्या प्रॉब्लम्स आ सकता है, आपके इवेपोरेटर कॉइल्स चोक हो सकते हैं, द फिन्स कुड बी चोक्ड, योर फैन कुड बी चोक्ड, सो आई विल कम टू ऑल दोस थिंग्स लेटर ऑन, ठीक है ना? इट इज, you have to just imagine how my the numerator here can be reduced. If it can be reduced, the opposite of it, if I increase it, then my COP will increase. Do you agree?
यस सर।
Suppose karo, if my evaporator coils are choked, okay, or if evaporator coils में कैसा रहता है ना आपका, like these are the coils and there will be fins, just like your air compressor में I told you about the, किसके बारे में बोला था?
एयर को
एयर
What
कूल्ड
was
कंप्रेसर,
एयर कूल कंप्रेसर
radiator?
से
Radiator बोला था, radiator में आपका
यस
fins
सर
रहता है, right?
यस
So
Yes.
here also these evaporator coils, from the inside your refrigerant is flowing, and from outside a fan is throwing air onto this tubes. Okay. And this air will, it will reject its heat into your refrigerant, and refrigerant will become hot, isn't it? That's why it is changing state also from liquid to vapor. Okay. Now suppose if these fins are choked somehow with dust and all, will you get that much of COP? आपका अभी amount of heat extracted from the reefer room will drop, isn't it? नहीं समझ आ रहा है?
आ रहे सर।
Tell me guys, not unable to understand or this? Suppose for example, एक example दे रहा हूँ, I will discuss it later on actually, ठीक है? COP, how you can improve it. Okay, suppose COP is basically, with your definition itself, it is amount of heat extracted from the reefer room through evaporator. So if any problems comes to your evaporator, what is evaporator? Coils हैं, okay, like this coils are going, and from within your refrigerant is flowing. Okay, these coils are having fins to increase the surface area, right? Fins are always provided to increase the surface area. So these are your fins, and there will be one fan here. Okay, this fan will be throwing your room air onto this fin, onto these tubes, the evaporator tubes. Agree?
यस सर।
From which your refrigerant is flowing. Okay, guys, are you with me?
yes
Just
sir.
यस
like
सर
just like your air compressor, right? Now this air will be hitting on these tubes, and then only it will be transferring its temperature to your refrigerant. And that's why a liquid refrigerant will become hot and it will go out as a gas state. Agreed?
Yes sir.
And when in doing so, this air will become cold, the room air. Do you agree?
Yes sir. Yes sir.
Okay. For example, suppose these fins are choked. Okay, dust and all for all those things, these fins are choked. What is going to happen? My performance is dropping or increasing?
Dropping.
Drop kar raha hai, isn't it? My performance will drop. So what I need to do in order to improve its coefficient of performance, I need to clean it. Agreed?
Yes, sir.
जैसे आप अपने कंप्रेसर्स का एयर कंप्रेसर्स का क्लीन करते हो कूलर दिस व्हाट यू से the cooler you clean it, right? For what purpose? To increase its efficiency? Do you guys relate to me what I'm saying? This is
Yes, sir.
one of the step, okay? And other steps I will discuss later when I will tell you about your cycle first of all. Huh? Sorry, components we have to understand what all the components that are coming in your complete cycle, then we will understand. This is one example I have given you. Is that example understood to you or not?
Yes,
The
sir.
one who asked the
Yes, sir.
question.
Yes, sir. Yes, sir.
Yeah, okay. We will discuss it later on, don't worry. Okay. Now the pH diagram. Okay. So this is your where your evaporator comes. Guys, you all know what is evaporator, right? Do I need to explain it? What is evaporator? Anyone who does not understand? I told you there are four basic components. Compressor, okay? Compressor will compress your refrigerant, okay? Then there will be condenser, agreed? Condenser will make it into the liquid state, your refrigerant, and then there is coming what? Your expansion valve. And then evaporator. Evaporator and condenser are both heat exchangers. Heat exchangers, I think everyone understood, right? What is heat exchanger? Shell and tube.
Yes, sir.
Okay. Heat exchanger. It is also a kind of an heat exchangers only, condenser and your evaporators. Okay. It is actually a heat exchanger. Okay. So this is the diagram for your pH diagram. Okay. Now, I use maybe red color. If you take the note from here, this line from here to the other end, this line is known as saturated vapor line. Okay. This line from the other end, now this is known as saturated liquid line.
So from where to where it is?
बीच में एक पॉइंट लगाया ना, वहां से लेके नीचे तक, ठीक है, till here.
Till okay. Okay.
So I can say that if this particular region, okay, I will give something one. Okay, this particular region is where my now this particular region is everything here will be in vapor state. Do you agree? 100% vapors. Bolo. If that is saturated vapor line, any cycle that is coming out of it, that means यहाँ पे vapors है. Do you agree?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Now whatever will be on the opposite hand side, if I'll take it as in light blue color, now this part is what it is telling me,
Liquid.
liquid. Oops, थोड़ा सा गलत हो गया. This is completely liquid. 100% liquid, huh? Liquid. But what it is in between?
Liquid plus vapor.
Yes, it will be liquid plus vapor. जो इसके बीच में था. This will be liquid plus vapor. So अभी इस डायग्राम के हिसाब से देखो, if I'll start from, for example, I will start from a compressor. So at compressor, is my liquid compressible? These compressors are normally your piston type compressors. So is it allowed if any
No, sir.
liquid comes to your compressor? No, right?
No, sir. No, sir.
Right? So only vapor should come. So you will see the compressor is basically in the vapor states always, cycle, right? After the compressor has compressed your refrigerant, okay, the gas, it has compressed it will be still in vapor state, right? After that, it is going to condenser. Agreed?
Yes, sir.
I will just name it. Number 1 to 2 is your compression cycle. Number 2 to 3, it will be your condenser cycle. Number 3 to 4 will be your uh, expansion cycle. Okay. I will draw one more diagram here just so that आपको अच्छे से समझ आ जाए. This is evaporator. अच्छे से बनाते हैं. This is important, guys. हाँ, ये पूछते हैं. This is the basics of RAC. ये समझोगे, then you will be able to answer a lot of cross questions and all. And if somebody is not able to understand, please right now let me know. अगर कुछ नहीं समझ आ रहा है, ठीक है? ऐसे आगे बढ़ने का कोई मतलब नहीं रहेगा. This is my compressor, and then I have a condenser, and then I have TEV, thermostatic expansion valve. Okay, this is number 1, number 2, number 3, and number 4. So 1 to 2, always your refrigerant will be in your vapor state. Then from 2 to 3, it will reach to condenser. Agreed? And in condenser, what it will do?
Yes,
The
sir.
refrigerant that is flowing inside, it will reject the heat. Heat निकालेगा अपनी, पानी का टेम्परेचर बढ़ेगा, whatever the cooling media is, right? That is what condensers does. ठंडा करता है ना आपके मीडियम को.
Yes, sir.
Yeah. Any cooler, what it is doing? It will try to cool it down, the whatever it is coming. Right now, my refrigeration that it will be coming, the refrigerant that it will be coming from here, that will be hot. If I want to cool it down, I will send it to the condenser. Condenser will reject the heat. Okay, uska heat nikalega and it will try to convert it into liquid. But you can see till here to here it is in liquid plus vapor state. यहाँ पे agree? In between this curve, saturated vapor line and your saturated liquid line, in this part, particularly, if I'll shade it, अगर नहीं समझ आ रहा है, यहाँ पे it will be in liquid plus vapor state. But
Yes, sir.
I want it to convert it into 100% liquid. So for that particular region, I am providing certain degree of subcooling, and that is this part. From here to here. Color is very bad. So this is from this point to this point. Now this is known as subcooling. Is it understood? सब कूलिंग देना पड़ता है, सो दैट नो व्हाट यू से, no vapors goes ahead, only liquid state it should go, right? uh, where is it, this one here. So this line is particularly for saturated liquid, and this one, it is subcooling. Subcooling is given in your condensers, okay? So that temperature drops further down more than the saturated point. Is it clear?
Sir, how is this subcooling attained? With the help of seawater, right?
I will tell you later on, okay?
Okay, sir.
Subcooling is a design feature. Suppose karo, for example, this is my condenser tubes. Okay, this is my condenser. So here, what is flowing inside the condenser outside? यहाँ पे क्या flow कर रहा है? In this part?
Water, seawater.
Seawater, right? Agreed. Seawater, or your, if your LTHT system is there, then your LT water.
Fresh
Okay.
water. Yes,
Sea
sir.
water. अभी के लिए sea water मान लेते हैं, ठीक है? Sea water is flowing out, and this is out. Okay. Now the refrigerant is flowing from inside is right now at what state? At the inlet in the condenser? Vapor state, right?
Yes, sir.
Compressor से निकल के vapors में आ रहा है, right? Suppose by till reaching till here, it has already converted into liquid. Okay. After it is rejecting the your heat to your water, it has already reached in a state in which it has already converted into liquid. After this, whatever extra coil is there, that is provided for subcooling. That means the temperature should further drop down. Is it understood? Just to
Yes,
make
sir.
sure that no vapors goes forward. Is it clear?
So basically, we increase the area.
Yes. You are increasing number of tubes, and accordingly, you will be
Do
doing
those
subcooling.
subcooling.
Okay? About 5% of subcooling is done. ठीक है? अगर और डिटेल में जाना है, so about 5% of subcooling is given in your condenser itself. Is it clear? Now you can
Yes,
see, agar if I take the tapping from here and I will give to expansion valve, don't you think my liquid and vapors are going? यहाँ in this region it is liquid and vapors, right? देखो, do you agree?
Yes, sir.
That is why I have to provide a subcooling to it, so that it should change 100% into vapors. The refrigerant that it is flowing in the system should change to 100% liquid state. Is it clear?
Yes,
Bolo,
sir.
is it
In
clear?
normal, sir. Yes, sir. But in normal, this domestic refrigeration system, how this subcooling is attained?
Because of the construction of your condenser.
So वहाँ पे cooling कैसे होता है sir? जैसे we have seawater over
Cooling is
here
done
in
by
the.
your seawater, isn't it? Seawater or
Yes, sir.
your fresh water, whatever system is there on board your ship. But उस condenser का length कितना है and how much capacity it is. If it is more than little bit than what is actually required, okay, then that means I'm giving some certain degree of subcooling to it. जैसे मैंने आपको explain किया, I
Yes,
have a
yes, sir.
tube, है ना? I have a tube, और यहाँ पे तक पहुंचते पहुंचते completely आपका जो भी मीडियम था, that in this case it is refrigerant, okay, and यहाँ पे वो vapor state पे आ रहा है, till here it reached, it already convert into liquid. So whatever now remaining tube is there, that will act as a subcooling media. It will cool it further
Yes, sir.
and make sure
Yes,
that no vapors are coming out of condenser.
yes.
Is it clear?
So I understood that, but I was asking that in domestic refrigeration system, how we cool, like we use cooling media as this seawater
If
in.
you have LTHT system on board your ship, okay, then you will be using LT water. ठीक है? Fresh water use करते हैं. If it is sea water system, then you will be using sea water. Condenser use होते हैं.
Yes, sir. So
Yeah.
that's what I'm asking. In domestic refrigeration, how we use what we use.
डोमेस्टिक रेफ्रिजरेंट इट इज, अच्छा ये जो घर वाले एसी को पूछ रहे हो,
Yes, sir. Yes, sir.
तो
Yes, sir.
दैट इज आपने अपने देखा होगा, यू हैव एसी इन योर रूम, इन योर हाउस।
Yes, sir.
हाँ, तो आपने देखा है एक तो वन यूनिट इज इनसाइड योर रूम, ओके, दैट इज योर व्हाट,
Evaporator.
Evaporator.
दैट इज योर
अच्छा,
इवेपोरेटर।
is
एक
that
ऊपर भी
air
लगा है,
cooled?
ऊपर
TV.
एक ऊपर लगा हुआ है छत पे, इन विच देयर इज अ वन फैन इज देयर,
Yes, sir.
अ फैन विल बी देयर,
Compressor
राइट?
or condenser.
ओके, सो इट यहाँ वहां पे विद एयर इट इज कूलिंग डाउन, ना वहां पे कंडेंसर में द कूलिंग मीडिया इज एयर, जो आपका
Okay, sir.
एटमॉस्फेरिक एयर है उसी से वो कूल कर रहा है उसको, ओके। एयर
Okay, sir.
फेंकता रहता है वो आपके कंडेंसर ट्यूब्स पे, ठीक है। दे विल बी वन फैन ऑल्सो, आप देखो उसका एक लाइन, एक और दो चीजें होती हैं आपके घरों में, राइट? वन इज इंस्टॉल्ड इन योर कैबिन, दैट इज योर स्प्लिट एसी, दैट इज अ कॉम्बिनेशन ऑफ इवेपोरेटर
And
एंड
TV.
टीवी, ओके। सो एक कंप्रेसर वाली यूनिट भी लगी रहती है, इन विच यू हैव कंप्रेसर and condenser, and there will be one fan also which will be throwing air to your condenser, okay, so that
Yes,
cooling
sir.
करने के लिए, ठीक है।
Yes, sir.
okay. So वहां पे एयर मीडियम है, एयर, ऑलराइट। now where was I? So is this understood? First of all, diagrams, what is subcooling and how it is achieved also, guys? Till point 3 it is
Yes,
understood,
sir.
यहाँ तक सबको समझ आ गया?
Yes, sir.
Yes, sir.
Yes.
All right. Now the next is, after this, it is going to the expansion wall. Okay. This expansion wall we will discuss in very thoroughly later on. Okay. It is going to the expansion wall. Expansion wall, I told you, it will convert some maybe 5% into, right now it is at expansion wall, what it is coming here? 100% liquid. Agree?
Fully liquid. Yes, sir.
100%.
After expansion wall, it might change to 5% gas and 95% लिक्विड, ठीक है। यहाँ पे एक्सपेंशन वॉल में यू कैन अंडरस्टैंड एक्सपैंड, ओके, इट इज एक्सपैंडिंग इट, ओके। आई विल एक्सप्लेन यू लेटर ऑन in very detail what is expansion wall, how it is working. For now, just imagine this, and you can see यहाँ पे गैस आ गया, so in what state it will be coming? The number 4 point, it will come in liquid plus vapor state.
Yes, sir.
Do you agree? Yeah. And
Yes, sir.
after evaporator, when it is going from the evaporator, outlet of the evaporator, I want to achieve which is 100%
Vapor.
vapor,
Yes.
because I don't want liquid to go into my compressor, otherwise piston टूट जाएगा, isn't it? Do you agree?
Yes, sir.
Yes,
Yes.
sir.
So, in order to provide this 100% vapor, I am giving something which is known as superheat. Just like in your condenser, I'm giving subcooling. Here I'm giving superheat, and superheat is a design feature of the evaporator itself. Same funda. Okay, same funda. This is the coil. When your 95% liquid is going into it, it will change in this much area itself. It will change to 100% vapor. Whatever is remaining afterwards, that is superheat. Is it clear, guys?
Yes,
Okay.
sir.
Number at one point only your evaporator cycle is finishing, right? So उससे पहले ही आपका superheat is coming. Is it understood?
Yes, sir.
Okay. All right. So this is regarding your pH diagram. Will you be able to explain the pH diagram if it is asked?
Yes, sir. Sir.
All right. Okay. Similarly, they will sometime ask you to draw a, इसमें explanation नहीं मांगते, they just ask you to draw TS diagram also. Okay. So the TS diagram for your refrigeration cycle is this one. This is obviously saturated vapor. This is saturated liquid. Diagram, TS diagram comes like this. So this is 1, 2, 2 dash, 3, 4. So 1 to 2 is obviously your compression. Okay. Then from 2 to 3 completely it is your uh, condenser part, 3 to 4 expansion part, and 4 to 1 is your evaporator part. Okay, just draw this diagram because they will ask you to draw TS and this diagram. ठीक है, अगर इसको और ज्यादा अच्छे से बनाना है, like completely you have to draw it correctly. So this 3 point will go somewhere here and then it will come. ठीक है, that is depicting your subcooling also, and this is also going to extend slightly ahead from this number 1 point. Okay. Ah. Okay, I'll show you maybe यहाँ पे होगा कहीं ना कहीं. Hold on. TS diagram of refrigeration cycle. Like this. See, this is the one that I've showed you, है ना? Isn't it? Guys, you can see this, right?
Yes, sir.
This is the one I've showed you. But if you want much more in a better way, then this is the one जहाँ पे आपको superheat and uh, about your
Subcooling.
subcooling भी दिया होगा. Let me just save it. Okay. TS has to be saved. I'll just बनाने से better है. I'll just paste it over here. So actual diagram will be looking like this one. सेम थिंग ही है, ठीक है, जो हमने अभी पढ़ा है. ठीक है, नथिंग मच डिफरेंट हियर. What is it? सेव नहीं हुआ क्या? ये रहा. Okay. ठीक है, इतना काफी है. जूम. This is your TS diagram. Okay. Is it clear? So you
Yes,
can see
sir.
the subcooling part. You can see the superheat part. ठीक है. Subcooling compression diagram is this one. So the one that I'm going to indicate around that will be your actual cycle. Okay, from here to here. Then from here to this is condenser cycle. Then subcooling, and this, and from here to like this. This is the actual cycle, and center part is a normal one. Okay. So this is your TS diagram. Okay. All right. Can I move
Yes,
forward?
sir.
बाकी चीजें थोड़ी.
Yes, sir. Sorry, for superheat, we used we have thermostatic expansion valve, right? That will maintain
For
around 5
superheat,
to
for superheat.
for maintaining superheat.
Hmm.
We have a TV. We have which will maintain
No, no,
about
no.
5 to 6%.
No, no. सुपर हीट के लिए टीईवी नहीं है, सुपर हीट इज अ डिजाइन फीचर ऑफ माय इवेपोरेटर, है ना, इवेपोरेटर
अच्छा
के साथ ही आ रहा है। डोंट यू थिंक फ्लो टू वन इज इवेपोरेटर, राइट? आप देखो, अगर इसको मैं ए डैश कर लूं तो ए डैश टू वन इज सुपर हीट, एग्रीड? So it is a
yes sir
design feature exact only for your evaporator, not related to your expansion valve. Do you agree?
okay sir
All right. Okay. Guys,
and
any other
subcooling
questions till now?
and
Bolo, हाँ,
subcooling
bolo, bolo.
is also a design feature of condenser
Condenser itself. Okay, nothing else.
okay sir okay sir
Yes,
and
guys.
how we
Anyone?
will
Hmm.
calculate that only 5% is
That is
subcooling
decided
is
by the
mounting
manufacturers. That is decided by the manufacturers, and when they will supply you condenser, they will mention in the booklet like how much is the subcooling is. Okay.
okay sir
Normally, okay, it is 5%. Okay.
okay sir
Just give me a minute. I'll just drink some water and come on.
भाई फंक्शन 4B का क्वेश्चन है तो पोस्ट कर दो यार।
Okay. So any questions till now? बोलो भाई लोग। अभी तक जो पढ़ाया समझ आ रहा है? Everyone, are you able to understand what I've said to you till now?
Yes, sir.
Okay. Any other questions related to this till now? I have 19 guys over here. Okay, 18 actually. So for now, you guys understood what I've said? Okay.
Yes.
All right. So I'll move
Yes, sir.
forward. Okay. Now we will understand few small things like what is specific heat, what is sensible heat, what is latent heat, because sometimes this is also asked, okay, in cross question. Then